organized by the Department of Computer Science and Engineering and IEEE Student Branch SMC. Thanks for joining the session. It's my pleasure to introduce our guest speaker for today, Dr. Tasneem Bano Rahman ma'am. We are honored to have the ma'am. Ma'am is a distinguished academic and researcher in the field of computer science and engineering with a PhD from Maulana Azad National Institute of Technology, Bhopal. Her research focuses on mobile ad hoc networks, cloud computing, sensor networks, edge computing, Internet of Things, and theoretical computer science. With over 15 years of experience in academic and research, Dr. Rahman has served as an associate professor at several prestigious institutions like Lakshmi Narayana College of Technology, Bhopal, Sri Ram Institute of Science and Technology, Jabalpur, Technocrats Institute of Technology, Bhopal, Sage University, Bhopal, and ma'am is currently working as an associate professor in Mufakam Jha College of Engineering and Technology, Hyderabad. She has also worked as in research and development projects at Maulana Azad National Institute of Technology, contributing significantly to the technological advancements in wireless communication and AI applications. Dr. Rahman has authored numerical research papers published in SCI, Scopus, and IEEE Index journals. She has also served as a reviewer for the leading journals including Elsewhere, Springer, IEEE, ACM Transactions on Networking. Dr. Rahman is the author for 2 books on cloud computing. At the same time, she holds multiple patents in IoT-based healthcare and AI-driven smart devices. Ma'am has received several certifications and recognitions, including IBM Certified Enterprise Design Thinking Practitioners in 2020, Leadership Skills Certification from IIM Ahmedabad 2023, and a grant of 1.75 lakhs from MPCST for organizing IEEE International Conference in 2022. So I encourage all of you to actively participate and make most of this opportunity. So now I request ma'am to proceed with the session. Hello.
Yeah, I'm sharing the screen.
Yeah, sure.
Is it visible?
No, ma'am.
Now, is it visible?
No, ma'am. Still, it is not visible.
Still, it's not visible?
Yeah, ma'am. Not visible.
I don't know.
Arun sir, I think Madam has given the presenter.
Sir, given sir, presenter access. Sir, presenter
Okay.
access given. Given sir.
Is it
Right,
still
fine.
not visible? I don't know why. I'm sharing the screen still. Still, it's not visible. So, can I share it to Soumya?
Madam,
I don't know why.
yeah, you please share PPT to one of the organizers.
Yeah, I'll do that.
Arun, Madam number unda నీ దగ్గర?
Sir, in sir.
Do you have Madam number?
No, sir. Soumya
Do you have
madam
Madam number? Okay.
I have sent to Dr. Shanti Makka.
Okay.
I've made
Madam, one thing you do, you just forward to me also. So I'll forward to
Okay, sir.
Dr.
Sure,
Arun.
sir. Yes, sir. I have made you also. Am I able to share my screen? Still, it's not visible.
No, ma'am, still it is not visible. Have you shared, ma'am, to sir?
Yes, I have shared to Jabbar sir and to
I think sir is sending now to Arun sir.
Shanti, ma'am. I mean, I
Yeah.
received an invitation from.
షేరింగ్ కూడా వెళ్ళట్లేదు. Arun sir, I shared the PPT to you. From your
Okay,
side,
sir.
you try to share.
Okay, okay, sir. Okay.
So till the time I think the presentation is being shared on the screen, let me just wish you all good evening. And I'm Dr. Tasneem Banu Rahman. I'm an associate professor at Computer Science Engineering Department in Mufakkam Jha College of Engineering. So today I'm really excited to be a part of this 1-week professional development program organized by Computer Science Engineering Department of Vardhaman Engineering College. And I'm also thankful to Ms. Soumya, Dr. Shanti Maka, and Dr. Ramesh to invite me for this insightful program. And I hope this session spark few ideas towards research in the area of edge, and hoping that you all get benefit out of it. Shall I send to someone else also, or?
Madam, wait for 2 minutes. Sorry.
Okay. We are already 10 minutes late. So shall I start?
Ma'am, is my screen visible?
Yes, it's visible, but can you do it full screen?
Yes, ma'am. 1 minute. Is it fine, ma'am?
It's not visible, ma'am.
1 minute. I'll share again. Now, ma'am?
Yeah, it's visible, but it's not in the full screen.
Wait a minute. Now,
Yeah.
ma'am?
It's visible. Yes, yes.
Okay.
Yeah, so the topic of today's session is empowering education with edge computing, redefining the learning journey. So let's examine the conventional education system to understand the necessity of integrating technology into teaching and learning. Next slide. So the traditional learning is often referred to as conventional or a classroom-based learning. It's a time-tested approach to education that has been the foundation of teaching and learning for centuries. And usually we all have gone through that phase where we had this conventional classroom-based learning. So it typically involves face-to-face interaction between teachers and students in a physical classroom setting. So let's look at the various characteristics of the conventional based traditional learning. Ma'am, next slide. Yeah, after this, what has happened to the slides? Yeah. So for the characteristics, let's understand how traditional learning we had it in the previous early years. So it was predominantly teacher centered with lectures, textbooks, and exams forming the core of the education. While these methods have been effective for years, they often have limited flexibility and fail to accommodate diverse learning styles. So the first characteristic here is the teacher-centered approach. The teacher is the primary source of knowledge and authority in the classroom. Students are expected to listen, take notes, and follow the instructions. The second characteristic is the structured curriculum. So the learning flows in a fixed syllabus or a curriculum, which is often determined by certain boards or institutions. So subjects are taught in a very linear and a step-by-step manner. The third is the physical classroom setting. So the learning takes place in a physical environment, such as school, colleges, or the training centers in a proper classrooms. So students and teachers used to interact in person. Next is they have a fixed schedule. Classes are held at a specific time and it follows a predetermined timetables. Students are required to attend classes regularly. The fifth is the standardized assessments. Learning is evaluated through exams, tests, assignments, and then the grades or marks were given to measure student performance. And the last is the group learning. Students learn in groups or in classes, and they used to collaborate, and there are peer interactions between them. Group activities were being carried out, various discussions and projects are among this group learning. So next slide. The methods of traditional learning. So methods are the lectures. Teachers deliver information through spoken presentation. Students listen and take notes. The second is the textbooks and the printed materials. So the learning relies heavily on the textbooks, handouts, and other printed resources. Third is the classroom discussions. Teacher facilitate discussions to encourage critical thinking and knowledge sharing. Hands-on activities are being carried out, which comprises of practical demonstration, experiments, lab work to reinforce the theoretical concepts. Then next is the homework and assignments. Students usually complete the task outside the class. Homework is being given, or whatever has been taught in the class, they need to apply what they have learned and come up with their homework. And the last is the examinations. Formal tests and exams are being conducted to access student understanding the progress. So can you, any one of you can tell me what are the pros of these traditional learning? Anyone? What are the advantages? Like, we all have gone through that conventional classroom. So if you compare to the present learning trends, can you just list out or just share any of the advantages of the traditional learning? I hope I'm audible to everyone.
Yes,
I just
ma'am.
wanted
Yes,
everybody
ma'am.
to be present. Anyone,
Yes.
like, what are the advantages of traditional learning? Not audible. One thing that we are missing today is the face-to-face. Yeah, we are doing this online. So of course, one of the advantage of traditional learning is to have face-to-face interaction, and that allows direct communication between teachers and students. Anyone else who wants to add any of the points for the advantages? Any of the positive points that you remember studying in a classroom, teacher teaching you? Any good memories that
Madam,
you
you
have?
can have it in the chat, madam.
Acha, everybody is replying on the chat?
Yes, yes.
I didn't check, sorry. I think chat is disabled. Oh, okay. Yeah, interactive sessions, students, right. Okay, fine, yeah. So you have more access to resources, you have social interaction, you have a structured environment, you have an organized framework of learning. So yeah, of course, there are advantages of traditional learning, but of course, let's look at the limitations of the traditional learning. Next slide, please. So the limitation of traditional learning, next slide. So the first is the limited flexibility. So you have a fixed schedules and location, which is may not be suitable for a learner to be regular with that, especially those with other commitments and location issues, right? So the second is the one size fits all approach. So the standardized curriculum may not cater to individual learning styles or paces. The third is the passive learning. Students may become passive recipients of information rather than active participations in the learning process. And the next is the geographical constraints that I just told you, that student must be physically present in the classroom, which can be challenging for those in remote areas. Then, of course, there's a limited use of technology. So traditional learning often relies on digital tools, which can limit access to modern resources and methods. The last one is the pressure of exam, of course. Overemphasis on the grades and exams can lead to a lot of stress and anxiety among students. So next slide. So can you give me some example of traditional learning in practice that's still in practice in the present scenario? We have school education where we have got fixed, school buildings, university lectures, college lectures. Again, there is a fixed infrastructure, and you have teachers coming teaching you textbooks are being referred, then boards are being utilized. Even vocational training centers are one of the example of traditional learning, which is in practice in the present scenario also. So today's education system is shifting towards technology driven, which is more student centric. learning. So this includes personalized, skill-oriented, and flexible learning experiences that leverage advanced technologies such as AI, cloud computing, and edge computing. Next slide, please. So let's first see various characteristics of modern learning. So modern learning is all about making education more engaging, more personalized, and practical. So instead of just memorizing and sitting through lectures, it embraces technology, interactive methods, and real-world applications to help students truly understand the concepts and apply what they have learned. So the first is the student-centric approach. It promotes active participation, collaboration, hands-on experience. Second is the self-paced and personalized, tailors learning to individual progress. As per the individual learning capabilities, these are being tailored as per the needs and the preferences. Next is the flexible and accessible. It allows learning from anywhere with internet access, offering convenience. Next is the technology driven. Technology driven is using advanced tools like interactive whiteboards, AR, VR, AI, ebooks, and multimedia. Next is the skill oriented assessments. It focuses on critical thinking, problem solving, and real world applications with real time feedbacks. Next is the dynamic learning environment, where you create an engaging and interactive experience using digital platforms and gamified tools, which is more actively being utilized by the students. So gamified tools, you might be aware about it, like Kahoot and Duolingo. Next is the global collaboration. So it connects students across regions for group projects and shared learning experience. Next is cost effective. It reduces expenses by minimizing reliance on the physical infrastructure and the printed material. Nowadays, all the students want, madam, please share the PDF. So everybody has moved towards, just forget about the books. They have moved towards PDFs and soft copies. Yeah. Next is the cost effective. So it reduces expenses by minimizing reliance on physical infrastructure and printed material. Next is the continuous learning opportunities. It supports lifelong learning through online courses, certification, and skill building resources. Next is the environmental friendly. Of course, there's there's no restriction with that. So of course there is a reduction in the paper use because everything is available online, and it promotes sustainable learning practices. Next slide. It tells you about the differences of conventional and modern learning, which we have already talked on. So we can move on to the next slide. Next slide, please. So now let's understand how technology is revolutionizing education, making it more personalizable and flexible. And these three key innovations are majorly used in the technological based learning, that is AI, edge computing, and cloud computing. So when we talk about AI has transformed learning apps by providing personalized, efficient, and accessible education experience. AI algorithm can analyze user data, learning patterns, and performance, and then tailor content and recommendation to individual needs, ensuring a more effective learning journey. The second is the edge computing. Of course, edge computing is gaining traction by bringing data processing closer to the source of data generation, which of course results in latency reduction, enabling faster processing of complex tasks directly on mobile devices. So the combination of AI and edge the combination of AI and edge computing in learning apps facilitate offline learning capabilities and even improve the data privacy part also. So in edge, it's like processing data locally on the devices, we'll understand what this statement means. So these apps can function without constant internet connectivity, making education more accessible in areas with limited network infrastructure. Next is the cloud computing. So cloud computing complements these technologies. It's slide 10 only, yeah. So cloud computing complement these above technologies by providing scalable storage and processing power for large data set and complex AI models. It enables seamless synchronization of user progress across devices and even facilitate collaborative learning experience. So let's see, next slide, the benefits of cloud computing in modern learning. Slide 11, ma'am. Yeah. So here, this is something which you people might be aware about cloud computing. So it's a delivery of computing services over the internet instead of using local servers or personal computers. These services include storage, processing power, databases, networking, software, and analytics on a pay-as-you-go basis. So the benefits that that's coming from cloud computing, the major benefit is the scalability part. So it can handle increased amount of traffic during high demand periods, such as if we are talking about education, then during exams or live classes, it can work very efficiently without any downtime. So automatically it can adjust resources based on the usage. The next is data storage and accessibility. It stores a massive amount of educational content such as videos, notes, quizzes onto the cloud. And it enables learners to access these materials from any device, anywhere, anytime. Next is the real-time collaboration. It enables real-time collaboration among students and teachers, like shared whiteboards, live annotations, group discussions in virtual classroom, and synchronize data across devices for seamless collaborations. So analytics, it facilitates data-driven insights and decision-making at a very efficient way. Next slide. So next we'll look at the benefits of edge computing. It's not visible. Yeah, it's visible now. Benefits of edge computing. So edge computing brings computation and data processing closer to the user's devices or location. So first benefit is low latency. So for real-time features like live quizzes or adaptive content updates in virtual classroom, edge computing reduces latency by processing data locally rather than relying on a distant cloud server. Second is the enhanced privacy and security. So sensitive data like user progress or biometric feedback, they can be processed locally onto the edge devices, reducing the need to transmit the entire data to the cloud. And of course, if it's on the cloud, you need to have privacy concern with that. So yes. Next is the offline capabilities. Edge computing allows learning apps to function in areas with limited or no internet connectivity. Data processing and caching happen locally, and updates are synced to the cloud once the connection is restored. So you don't need to have internet connection while you're using the app throughout. You can have, imagine like in rural areas, the learners and the students can access and interact with these pre-downloaded content without needing to have a constant connection with internet. Yeah. Next is cost efficiency and so by performing certain computation onto the edge, the volume of data sent to the cloud is of course minimized, and this will of course result in the cost reductions and the network strain that is being there if we use onto the cloud. It's more onto the edge. So of course, it's going to reduce the cost as well as it will reduce the bandwidth usage. So example, you can imagine a video-based learning app can transcode or compress videos on edge devices, sending only the critical metadata or analytics to the cloud, not the entire video. It's coming and going from cloud. So yeah, those were the benefits. And let's have a next slide, which shows the comparison of cloud and edge computing in education. So here you can see the major important thing is about the latency. So the latency is being reduced at a very higher rate because of the faster response time, because we don't need to go to cloud, do the processing and come back. That's to and fro distance is being cut short. So yes, cloud computing has a higher latency. If we talk about internet dependency, edge can work in offline modes or minimal connectivity, whereas cloud needs to have a proper and stable internet connection. Then the performance, of course, if we look at in the education sector, so these real-time processing, especially in the interactive learning for AR, VRs, quizzes, and the feedbacks, the results that are being generated, this everything, it's the performance has increased because of the low latencies. Whereas the cloud scalable computing for big data, AI-driven recommendation, all the things are happening at the cloud. So of course, it affects the performance. The security privacy part that I told you, that it's better control over data privacy in the edge computing rather than the cloud computing. The scalability part, yes, of course, there's a limitation because we have less power, less energy, less memory at the edge. So of course, there's a limit to the device capabilities. Whereas on the cloud, you have, and I mean, it's uncountable kind of thing you can imagine. So it's easily scalable for multiple users. Use cases are real-time AI feedbacks, interactive simulation, VR, AR classrooms, device-based assessments. We'll look few use cases in the coming slides. And the cloud computing are the online learning platform, all the MOOC courses, collaborative tools, AI-driven recommendations. Yeah, next slide. So now with this, we understand why we are shifting from cloud to edge computing. Next slide, yeah. So there's a significant shift occurring from centralized centralized cloud computing to edge computing across various industries. It includes education also. And this transition is driven by, the first is, of course, the increasing amount of data generated by IoT devices in smart classrooms, significantly contributing to the growing demand for efficient cloud computing solutions. So these devices include sensors, cameras, smart boards, which continuously generating a vast amount of data, and that data need to be processed quickly to provide real-time insight and feedbacks. This creates a need for faster, nearly a real-time analysis and responses to ensure that teachers and students and administrators can make timely decisions based on this data. However, if we talk about cloud computing, the traditional cloud model, what is happening is we are relying on the centralized data processing in a very distant data centers, which struggle to meet the new user demands. The vast volume of data which is being generated by the IoT devices can overwhelm a traditional cloud system. And it can cause network congestions and higher latencies. So this can hamper the ability to process data quickly enough for application, especially for the live monitoring of classroom conditions and interactive learning tools or instant feedback during lessons. So moreover, the traditional cloud models relies on a single centralized infrastructure. And of course, it's becoming unsustainable as the number of devices and users grows. There's a need for more distributed, scalable, and efficient system is becoming quite critical to support the evolving requirement of smarter classrooms, prompting a shift towards more advanced cloud computing models such as edge computing. So now we are in a state to understand that why edge is better. Next slide. So edge computing has a potential to transform education by bringing powerful computational resources closer to learners and educators. It enables real-time data processing, reduce latencies, and improve the learning experience. This technology supports personalized interactive learning environments, integrating advanced tools like AR, VR, AIs. So additionally, edge computing improves accessibility by processing data locally, reducing network strains, and enabling content delivery even in a low connectivity area. So as education embraces digital transformation, edge computing will be key to creating adaptive and more inclusive learning experience. So let's just have a look on the edge architecture for a simple learning application. I have come up. Next slide, please. So it comprises of 4 layers. So sensor layer, edge computing layer, core network layer, and the platform application layer. So sensor layer, it comprises of sensors, IoT devices, data acquisition models, and it collects multi-sources heterogeneous data. That data can be an environmental sensor or IoT device or even a camera. So when these data is being collected, what this sensor layer does is so the raw data is sent, it's sent to the edge computing layer. So here the actual working takes place, the edge computing layer. So edge computing layer, the components can be edge nodes or edge servers or local processing units. Here the processes and filters data locally at the edge nodes to reduce latency and bandwidth usage. So in this layer, the processing takes place and it is then sent to the core network layer. So imagine if you have access to the Duolingo quiz. So in that, you learn a language and then they have a quiz. So once you are done with the quiz, automatically it gives you the result. So at that instant, you're getting the result. It's not being delayed. There is no latency. So here the edge computing layer is keeping this work. And whatever quiz results are being generated, they are being sent through core network layer to the platform application layer. So core network layer, it's just transmitting data between edge nodes and the central platform, ensuring reliable and secure communication. At the platform application layer, what is happening is it basically it provides educational services, of course, but actionable insights and the services and educational tools. It's the actual place where the entire data is being fed so that you can have an insight about that person learning progress. So this is how a learning application which is utilizing edge comprises or works in this way, manner. Next slide. So edge computing has revolutionized classroom learning. Here you'll see a few stats. So edge computing is gaining traction in education, particularly for real-time applications. You can see that global edge computing market is experiencing significant expansion. So in 2023, it was valued at approximately $16.45 billion and is projected to grow at a compound annual growth rate of 36.9% from 2024 to 2030, as per the Grandview Research report. So look at the amount of, how edge computing is globalized and being put up in various projects, and the rate is 36.9%. Whereas if you talk about the IoT in education, so 60% of the schools in developed countries are investing in IoT devices like smart boards, attendance tracker, and environmental sensors, which rely on edge computing. And the next is the AR, VR adoption. The use of AR, VR in education powered by edge computing is expected to grow by 45% annually, reaching to $12.6 billion by 2026. So this is how edge computing is taking a center place in the learning apps and various platforms. Yeah, next slide. Now you'll see the edge computing. Next slide. Edge computing impact on learning. So real-time feedback, as I just discussed with you. So edge computing enables instant feedback in adaptive learning system, improving student engagement by 30%. Of course, the moment student sees the result, so he is motivated, or he is aware that where he is standing, so how much he has to work. So real-time feedback is really important, which is of course reflecting on the student engagement part. Next is the personalized learning. School using edge-enabled adaptive learning platforms report a 25% increase in student performance. That's a good percent. Smart classroom. IoT devices in smart classroom powered by edge computing have reduced energy costs by 20% and improved resource management. So you must be thinking how it's related to energy cost. So you can imagine a classroom, which is of course a smart classroom, where you have got sensors, temperature sensors, and the lighting sensors. So quick decisions can be made to adjust these temperature and the lighting based on the actual occupancy and need of the room, rather than relying on the preset schedule. So of course, it is going to reflect on the energy cost also. So yeah. Next is the challenge. So infrastructure costs. Initial setup costs for edge computing infrastructure can be high, with 50% of school citing budgets constraints as a barrier. Of course, it's a little costlier. So many schools and colleges need to think before implementing. Next is the technical expertise. Over 40% of educators lack the technical skills to fully leverage edge computing technology. So we lack in these two scenarios. If these cost and the technical expertise part is there, then we could have fully utilized the edge computing power in the education sector also. Yeah, next slide. So let's see one, I think there's a example of AR/VR solution. Next slide, please. Yeah, AR/VR solution for edge, that's edge computing in action. There's one company, Eon Reality. It's a global leader in VR/AR solutions for education and industry. So Eon Reality is primarily a platform that includes both software and tools for creating and deploying augmented reality and virtual reality experiences. So it combines, of course, here you will see that this platform is utilizing both cloud and edge computing for scalable deployment and low latency. It has taken all the pros from cloud and pros from edge, making it much more favorable for any scenario. So here we can have a video. If you can click, and if you have the access, we can have. Can you click on this link? You can actually give you a feel how this AR/VR solutions have changed the education scenario.
Mom, is it visible?
No, it's not visible.
Oh,
Or maybe
one
later, if it's visible, I mean, if it's possible, please play. Otherwise,
let me
I'll
check, Mom. 1 minute.
yeah, this tool is really good if you're going for prototyping and simulation. So Eon Reality allows engineers to simulate and test design in a virtual space before they are physically being constructed or manufactured. And this is particularly useful for testing products or systems that are difficult, they are very expensive or time consuming to prototype in the real world. So engineers can conduct various tests, performance evaluation, and operational simulation, and check in this virtual environment before going for a physical prototype. I don't think so. It's let
No,
it
Mom,
be. I mean, if you are interested. Yeah.
It's 1 minute, Mom.
Oh, sure, sure.
Mom, now?
Yeah, it's visible. Can you play?
Yeah, I played, ma'am.
Okay. Okay. Okay.
Is it fine?
Yes. The audio is not
Oh, sorry.
playing. It's not audible. So this Eon reality, it enhances the entire remote learning, making knowledge transfer more interactive and engaging across schools, universities. It has a very immersive kind of experience and visualization, interaction with these 3D models. Environment, yeah, I think, ma'am, let it be. I'll share the presentation. Those who are interested, they can just go through it because it's not, the audio is not coming. It's
Okay,
okay,
can
ma'am.
I share
No
the
issues.
presentation, ma'am?
Yes, ma'am. So another VR that I would like to share, but you can just go through the video later onwards. It's MEL Chemistry VR. So it's meant for performing the chemistry experiments in a very safe environment. My presentation
Oh,
starts.
yeah, ma'am. Is it fine, ma'am?
Yes, it's coming, I think. Yeah. Next is MEL Chemistry VR. So it is an immersive education experience that combines chemistry learning with virtual reality technology and is a part of the MEL Science platform, which provides hands-on science kits for students. MEL Chemistry VR enhances this learning experience by using VR to simulate and visualize chemical reactions and experiments in a very safe, interactive, and engaging way. So there's also a video, but I think without audio,
Ma'am,
it
will
would be a
we'll
little
share
boring.
this links in the chat box, ma'am.
I share the link, is it?
No, I'm saying
Okay.
I'll share the link for them in the chat box
Okay.
later.
Okay. Yes. That's fine. Yeah, then we can move ahead. So these were the two very interesting examples of AR VR. Next slide. So now let's see that how or I should say why edge computing matters. Yeah. So the first is the lightning fast performance. Sorry. Yeah, lightning fast performance. So edge devices process student responses locally, providing instant feedback during quizzes or exams. So example can be a math app on a student tablet instantly evaluates answers and then provides the explanation to the students. So that keeps on, student engaged. Next is the enhanced immersive learning. Edge computing reduces latencies, of course, in AR/VR applications, which enhances its immersive experience. I told you about a few examples, and even the students use AR headsets to explore the 3D models of historical sites with edge devices, ensuring smooth translation. Then next is improve accessibility. Here, it enables offline or low bandwidth learning by processing data locally on devices. Like you can imagine a student in a rural area can use edge-enabled tablets to access interactive lessons and learn it without internet. So that's how we can say that edge computing matters to the present education system. Next, it's a flow of adaptive maths learning. it's a very interesting, I have put up the video also, but let's not talk about the video. So here there's a flow of learning app using edge computing. It involves in basically it involves an educational application that provides personalized learning experience by processing data locally onto the edge rather than relying on a cloud-based server. So let's understand the main objective of this adaptive maths learning app. So the app focuses on helping students practice and improve their math skill through real-time assessments and personalized feedback. So the first thing that's happening in the adaptive maths learning is first is the user interaction. So in user interaction, which component or which hardware you can visualize? Yes, it's an edge device. That can be a smartphone, tablet, or a smart glass. A student opens the app and starts solving math problem. So the app collects data on how the student interact with the questions, how much time they take to answer, and the type of errors they make. Then comes the edge processing part. So in edge processing, instead of sending the data to the central server, the app processes the student performance locally on the device using edge computing resources. It has got few AI models or machine learning algorithms. For example, an app might use an AI model. You might be aware about TinyML model. So that TinyML models are being used on these what do you say, constrained devices which has restriction with respect to memory, processing, and energy. So AI model to analyze the student response time, answer accuracy, and the type of question they are struggling with. So this model is pre-trained and it's optimized to run effectively on the device. Now next is the personalized learning path, that is local processing. So based on the data analysis, the app can adjust the difficulty of the next set of problem. For example, if the student struggles with multiplication, the app might give more practice problems related to multiplication. The app can also provide instant feedback, such as highlighting the steps of students which they are missing without waiting for a connection to a server. Now, next is the real-time recommendation. If the app notices that the student has mastered a certain type of problem, it could recommend more advanced topics to challenge him or her. So local AI models could even suggest additional resources like videos or tutorials to help students with a specific concept, and everything is processed on the device, right? Next is the edge computing advantages that's coming up. That is instant feedback. Yeah, of course, the instant feedbacks are being given without the need to wait for the data to be uploaded onto the cloud because it's processed in there only. Then offline functionalities. The student can use the app without an internet connections, as all the processing is happening locally. The next is the privacy part. Since the data doesn't need to leave the device, there are fewer privacy concerns and sensitive information remains on the device itself. So this is how a math learning app, an edge-based math learning app work. And the technologies which are involved in building this app comprises of AI model, edge device, and the local storage. So with this adaptive math learning app, I just showcase you how edge computing can enhance the learning experience by enabling real-time personalized learning without reliance on a constant cloud communication. So there's a video of that app. You can just check it later. So next, I just talked about TinyML. So it's really interesting to actually understand how locally edge is processing, because it has got a very limited memory, very limited processing and energy, because it is resource constrained, right? So let's see how it's working. I have put up this TinyML model workflow. So this tiny machine learning is all about bringing machine learning to devices which has limited resources, like microcontrollers or embedded systems. And these devices might not have the power of, might not have that amount of memory or that amount of power that a cloud server has. So tiny ML model are specifically designed to be small and efficient while still performing smart tasks. That's very important. So here you can see how it works. So first step is, it is showing the training. So the tiny ML model starts their journey by being trained on powerful machine. You cannot build up a model on a very restricted machine. You need to, am I audible?
Yes, ma'am.
Okay. So what is happening is these machines handle the heavy lifting processing, vast amount of data to help the model recognize pattern or make predictions. So everything is being done onto the cloud. And then once it is being trained, then the second step, which is important in order to keep, make that model run onto the edge, is we need to optimize those models to make sure that the model can run on a very resource constrained device. It's optimized. And optimization, there are techniques, there are 3 techniques which are being used: the quantization, pruning, and knowledge distillation is being used. So I'm not going into those details, but yeah. So this is how it is being optimized in order to be deployed on a resource constrained device, which would be an edge device. Now, the third step here is we are going to deploy that onto the edge device. Once it is optimized, the model is ready to be loaded onto the edge device. And these devices might not be as powerful as a server, but with the smaller optimized model, they can still perform tasks like recognizing voices, detecting objects, and even analyzing sensors data in a real time. Now, next is making prediction, that is inferences. So when the device receives new data, the data can be an image or sound or any temperature reading. So the tiny ML model process it and make a prediction or a decision right there itself on the device, right? Because it has its model, which is helping to build, to come up with these decisions and predictions. For instance, a camera might identify objects, or a microphone could transcribe speech without needing the cloud. So the next is operating continuously. So one of the biggest advantage of tiny ML is that it works offline. Yeah. So the model runs directly on the device, making decisions with low latency and saving both bandwidth and power. So this is a key for devices like wearables, health trackers, or voice assistants, which can keep working all the time without needing to have any constant cloud support. And the sixth is a low power consumption. Since many of these devices run on battery, tiny ML is designed to use as little energy as possible. This way, the device can last for long period without draining the battery, making them more efficient and practical for continuous use. So that was how tiny ML can be used to train, to build up a model for edge devices. Yeah, I hope it's clear. Yeah, next slide. I know we have crossed the time, but yeah, few more slides. Yeah, applications based on edge. So here I have put up a few small list of applications and websites that leverage edge computing for teaching and learning. These tools are widely used in education to enhance interactivity, personalization, and accessibility. So the first is application and websites based on edge learning is adaptive learning platform, that is Newton. I don't know if people have heard it or not, but it uses edge computing to provide real-time personalized learning experience and adapt content based on student performance and engagement. The second is Dreambox, an adaptive math learning platform that processes student data locally to provide instant feedback, and then tailored lessons are being provided. Next is the AR/VR learning tools, ZSpace. It uses edge computing to power AR/VR experience in education and enabling students to interact with 3D models in real time. Then there is Google Expedition. It leverages edge devices to deliver immersive AR, VR field trips without requiring constant cloud connectivity. And it was developed by what is that called? Yeah, it was developed by Google to enhance learning experience by bringing locations, historical sites, and scientific concepts to life through AR and VR. Then there's an offline learning app that is Colibri. It's a learning platform, and it uses edge computing to deliver educational content in low connectivity areas, especially it's meant for rural areas. And next is the Khan Academy Lite. There is Khan Academy and there is Khan Academy Lite. So this Khan Academy Lite is a lightweight version of Khan Academy, and that works in the offline. It uses edge computing to process and store data locally. Yeah, that was all about the few applications based on edge. Then these are the various use cases with respect to the platform and the best choices which can be chosen based on the use case. So the first is the LMS. In this, edge computing performs local caching for offline access, and the cloud computing has AI-powered adaptive learning scalability. And the best choice is, of course, cloud, because it's an online learning platform. Next is smart classrooms. So smart classrooms, of course, edge and cloud both has a very positive points, and that is why it's better to have an hybrid approach, and that is being provided by Microsoft Teams, plus these edge AIs that we have talked about. Next is the virtual labs. Edge computing, low latency AR, VR experiments are there, but cloud computing, it needs to buy cloud-based storage of lab and results. So of course, this is also hybrid. For the security and the surveillance part, the privacy part, of course, if you're concerned about the privacy part, then the edge is the best. And then the research data processing. Research data processing, of course, it requires on-premises and cloud-based collaboration. So again, it's a hybrid approach, which is the best choice. Student assessments and proctoring, again, it is best to have a hybrid of taking the best of these tools. So in the next slide, we'll see, next slide, please. Yeah, so next is the challenges. Yeah, after going through edge and cloud, now it's time to look at the challenges of edge. Edge computing devices have less processing power. From the very first slide, I was talking about less power, less energy, less memory. So yes, edge computing devices have less processing power than cloud data centers due to the size, power, and cost constraints. Have a limited space, and of course there's a cooling restriction processor performance, while battery dependence demands energy efficiency. So high performance hardware and multiple edge locations are costlier. So if you go for a specialized processor like ASICs, that is the application specific integrated circuits, or if you go for FPGA, that's field programmable gate arrays. So those are costlier. So of course, if you go and wanted to have a higher processor, high performance processor, then of course you need to pay a lot. So by looking at this, we can come up with the research direction. I have one research objectives that I can share with you all is the research can be carried on how can we improve architecture and algorithms to maximize efficiency while addressing these constraints, ensuring better performance and broader applications in various industries. This is one of the very happening research area that even you people can explore, and if you are interested in edge computing. So cloud computing offers many advantages, but it also raises data privacy and security concerns. So the key risks include data breaches from unauthorized access, loss or corruptions due to cyber attacks or hardware failures. So of course, we have challenges both in edge computing case as well as cloud computing. So next slide, yes. So now by looking at the challenges, we need to identify when to use edge and when to use cloud in the education sector. So we can use edge computing when real-time interaction is crucial. Like we want virtual VR labs, we are using it, and we need to make sure that it's real time. There is no lagging. Quizzes are there, AR learning tools are there. So yes, at that time, edge computing. Students have limited or unstable internet connections. So in that case, again, we need to be dependent on edge computing. Next is the security and privacy, of course, top concern. If you talk about the assessment or certain personal data of the student, then of course we need to make sure that the data is secure. Then when to use cloud is when you have a large scale of data which is to be processed, and in that case we need a powerful AI model. Next is student need remote access and collaboration tools. So yes, of course. Then of course scalability, number of users and amount of data is increasing every day. So in that case, of course, cloud computing, the example for the scalability one application is MOOC and the LMS platforms. Next. So now we have this question, why edge can't fully replace cloud? Can anyone tell me? After listening a long story from me, can anyone conclude and tell me why edge can't fully replace cloud? Anyone? Or you can drop in the chat box if you have any answer for it. Why edge can't fully replace cloud? Storage issue? Yes. Good. Yeah, somebody is awake. Cloud can store large amount of information, whereas edge cannot. Yeah, storage.
Sometimes
Anyone
it may
else? Any
I get the real live answer, or live processing.
Anybody? Yeah. Processing overhead, yes. Constraints with respect to? Just we have talked about storage. Any other constraint? You're forgetting one major word that I was using always. Scalability. Scaling resources globally. Cost of maintaining. Yes, very good. Cost of maintaining hardware. Hardware dependency is there, of course. Yeah, very good. Thank you, Mr. Ramesh, Mr. Kolarkar. Big issue in security. Very good, Mr. Omapathy. Yeah, thank you. I'm happy. I hope people are listening to me. Yeah, so edge computing enhances learning apps by addressing latency, offline functionalities, privacy concern, but it cannot replace cloud computing. Instead, a hybrid approach that leverage both technologies is the ideal solution, providing the scalability, the power, the intelligence of the cloud alongside the speed and the local processing capabilities of edge. So yes, the next slide will tell you the hybrid approach is the best. I mean, best of the both worlds. We can take it and come up with better and most efficient and most enhancing platforms. Yeah. So hey, I have given up two examples of hybrid approach. That's the smart classroom boards, that's Promethean, and the smart boards, which utilizes both Edge AI for handwriting recognition, Cloud Sync for shared lesson storage. Then there is Khan Academy, which I have told you that they are using Light for the Edge. So Khan Academy and Google Classroom, they are both utilizing Edge as well as Cloud. Edge for caching for the offline access and Cloud for personalized recommendation. So there are other platforms also, like we have, you might have also used Microsoft OneNote is there. Then Google Workspace is there. That is also a hybrid edge cloud learning tools. Yeah. So next slide, please. So we are almost done. Yeah. Overall, we have discussed that edge computing has the potential to significantly transform the education sector by enhancing the learning experience, improving administrative efficiencies, and enabling more personalized and interactive teaching methods. So both edge and cloud computing have transformative roles in modern education. So by combining their strengths, educators can create an adaptive, efficient, and personalized learning environment that prepares students for the future. So I think, yeah, that's it from my side. If you have any questions, you can ask.
Participants, if you have any query, you can ask.
May I request the participants to switch on their cameras, please? Is my voice audible?
Yeah, it's audible, ma'am.
Yes, you're audible.
Tasneem, ma'am, please.
Yes,
We
yes.
just wanted to take one.
Sure, ma'am.
Pawan sir, we are sharing the attendance link shortly. Madhurya, ma'am, simultaneously you keep the attendance link in chat as well as in WhatsApp group, ma'am.
Okay, ma'am.
Okay. Tasneem, ma'am, we want you to switch on the camera once, ma'am, please.
Yeah, it's on.
It's on, huh? I'm not able to see her.
Yes.
Okay, then whoever taking the screenshot, they're able to see, no? Okay, ma'am. Ashlesha, ma'am, you can, thanks, ma'am.
Yeah, thank you, Tasneem ma'am, for such an insightful and engaging presentation on empowering education with edge computing. We all learn a great deal from your talk today, that how edge computing can be useful in overcoming the limited flexibilities of traditional and conventional learning, at the same time helps in maintaining data privacy and cost efficiency. We also learn how edge computing processes data closer to the source without the need to send the information to the central server, which will be definitely helpful for all of us in our journey of teaching and learning process. Thanks, ma'am.
Thank you. It's all my pleasure. Thank you. Thank you.
Now I invite Dr. Shanti Makka, ma'am, to provide the brief about tomorrow's session. Ma'am? Shanti, ma'am?
Am I audible?